Okay, good morning. So let us continue our lesson. I will teach this new lesson. In the book, they have separated these topics under the title of double formulas, and then there is a set of formulas, their problems, and then they are talking about half angle formulas. But they are actually technically the same thing. I just want to teach them in one go so that you understand. You don't need to actually make a distinction between these two topics. Of course, in general, let me explain about that. But before doing that, let me just remind you a little bit of formulas because we will need them here. So if you don't mind, let me write them very small here. So what was the formulas? Let me change the color. So if you remember, we had 4 addition and subtraction formulas last time, yes? So number 1, what happens, let me write them small. U plus V is sine of the first one multiplied by cosine of the second one plus sine of the second one multiplied by cosine of the first one. And then you have similar thing here, so 2, it is, by the way, let me also teach you this convention. So here I can put plus and minus, I can put plus and minus. When you have this in mathematics, it means that if you start reading the upper sign, continue reading the upper sign until the end. And if you continue reading the lower sign, continue to do this until the end. Okay? So if I want to, so this is not one formula, this is 2 formula written in compact way as one single formula, yes? Is that understandable? Okay, and now number 2, what can I do for cosine u plus or minus v? If you remember, the combination was cosine u cosine v, yes? And then it was sine u sine v with another difference. Do you remember? If I had a plus sign, it should be a minus sign. If I have a minus sign, it should be plus sign. So I write it minus plus. So it means that when I start reading this formula, if I read the upper one, I have to keep reading upper one signs until the end. And if I read the lower one, the lower one. So it's a very nice way of writing this in compact form. So these formulas, we actually discussed, we actually proved where these formulas are coming from, and then we solved some problems related to them. So, for example, let me give you an example. I haven't started the new discussion yet. I'm just refreshing your memory by giving you some examples. So, determine, of course, without the use of calculator, determine the exact value of cosine 15 degrees multiplied by cosine. Let me see if there is a question in the book. It was nice. Let me solve that one for you. Yeah, this was the question. This is problem 1028. So let me write the number here. It's a level 2 problem without stars. So 1028 in the book. Determine the exact value. Of course, they haven't written determine the exact value. I'm changing this a little bit. So determine the exact value of this combination. In the book, they have given you the answer and have asked you to show why this is true. I am not giving you the answer. I'm asking you to determine the exact value. But this expression is exactly the one that I copied and pasted from the book. So determine the exact value of this combination. So the point is that even if you don't memorize these formulas, which usually you don't, but these kind of a structure should be familiar to your eyes. Otherwise, you are not able to detect the pattern in any way. Yes? So you see, for sine, we have a combination of sine and cosine again. For cosine, I have combinations of cosine, cosine, sine, sine. So these patterns somehow should be familiar to your eyes. Otherwise, you will not be able to detect the pattern. And if you don't detect the pattern, even if you have the formula in the formula sheet, how you should know you should use that? Yes? This is important. So now, can you detect this pattern now? Yes?
It has a square root of 3 divided by 2.
Yes, but why?
Because you follow the upper formula.
Formula, yes. If you see, it's a combination of sine, cosine, and the angles involved are 70 and 10. And again, I have a combination of sine and cosine in reversed order, but the angles involved are again 70 and 10. So it means that this might be the right-hand side of one of these formulas. Yes? There is no hope for having this in this case. Might be this is this case, and then because I have a negative sign, if this is going to work from these formulas, this should be formula 1 with the negative sign. Yes? Now I hope that you immediately realize that you can give the role of this to u and give the role of this to v. And if you say this is u, here again this is u, and here it is again v. And now read it. It becomes sine u cosine v minus sine v cosine u. And that's exactly the formula that you see on top. And the sign is negative. So what you can write it's equal to the sine. This blue one is the solution. What's the answer? U minus v. So u is 70 degrees minus 10 degrees. But then you know how to calculate, because this pair of brackets gives the priority to subtraction. So this becomes 60 degrees. But hopefully you remember this is at least one of those famous angles. If you don't have it in mind, you can go and find it and read it in the formula sheet. So what is the answer? If you look into the table, the answer is square root of 3 over 2. So that's the exact value. That's one way of doing that. By the way, I published the third set for interested students, okay? But let me solve some of them here for you. They are not, by the way, I gave one of these questions and A-level questions last time, okay? So let me just ask you, because I do not want to delve into it so much, because that's another topic. It's called Trigonometric Identities. Most part of it I will teach there. But let me just give you another example to refresh your memory a little bit, and give you some tricks here. I will complete it later. So example, show that for every angles u and v, we have, this is a nice relation. It's sine of u minus v multiplied by sine u plus v. We want to show that this becomes sine squared of u minus sine squared of v. Okay, so this is something that we want to show. So these kind of things, we will study them later. These are called trigonometric identities. So they are equalities involving some one or more angles, so that they are valid for a very broad range of variables. So for example, what is the most important identity in trigonometry? And that is what we call the etton, you said, yes? So sine squared theta plus cosine squared theta is equal to 1. That's an identity. Regardless of the value of theta, the left-hand side, sine squared plus cosine squared is always equal to 1. That's an identity, which is always valid. So that's also an identity. But that identity is so important that it deserves to be on the back of your formula sheet or in your head. But this is also an identity, but probably not that important, so we don't spend some time to memorize them. Okay? But that's also an identity. Okay, how should I prove this? Usually if you want to prove identities, you need to start from one side. If this, of course, this is not a necessity, but usually you start from one side, try to do some simplifications, and then reach to the other side. And the preference is to start with the side which is more involved, because then you have more opportunities to know how to simplify things. If you start from a simple thing, then you have to make it more complicated. Usually it is against your brain. We have learned to simplify things, yes? Okay, so what we can do, I would start from the left-hand side, okay? I will consider it a little bit more involved than that situation. So, some of you get this mistake. I have seen when I saw the solution, some people say that this is the conjugate identity. Yes? It is not the conjugate identity yet. If I had only u minus v times u plus v, that was a conjugate pattern. Yes? But I have sine of u minus v and sine of u plus v involved. They are not conjugate patterns yet. But what can I do you think? If I want to prove this, I can start from the left-hand side, for example. There is only one thing that I can do for sine u minus v. What is that? To use the formula. And the formula tells me that it is sine of the first one multiplied by cosine of the second one minus the other way around. Sine of the second one multiplied by the cosine of the first. What I have written here is just something that I put instead of the first one. For the second one, I can do the same thing, but with the positive sign. Okay? So this is the only thing that we could do so far. But now look at this product. Is this a conjugate pattern? Yes or no? This is a conjugate pattern because you can imagine in your head the name of this guy is capital A, so the name of this guy, which is the same, would be also capital A, and if I call this capital B, that is exactly the same expression, so that is equal to B. So this is a real conjugate pattern. So that I have two numbers subtracted, the same two numbers added, and I am multiplying them. So the answer to this is capital A squared minus capital B squared. Yes? So let me just write it. But capital A is what? Is sine u multiplied by cosine v squared. This is A squared minus B squared. Yes? Yes or no? Okay, now can I put this power of 2 here and there? Yes or no? 1 second. Yes or no? Yes. Yes, because that's a product, yes? If I have A times B to any power, I can write AN times BN, that's for sure. But if I have A plus B to the power of N, and if you naively write this, this would be wrong, yes? But that is correct. So, I would immediately write that this becomes sine squared u times cosine squared v minus sine squared v cosine squared u. Okay? So far, we have this expression. But I will teach this more in detail about general identities later. But here, I will have an eye on the right-hand side. This is very important to have always an eye on what you are going to show. Of course, this is not exactly equal to what I want to show. This one that I want to show seems much simpler than that combination. But these things you need to learn, because even if you follow what I am telling, if the problem is hard, you cannot still solve the problem. Let alone that if you don't want to follow these rules. Okay? What I think, I want to say that, okay, here I do not have any cosines involved. I have sine squared u, sine squared v. At least I see that I have two nasty cosines here, yes? Cosine squared v and cosine squared u. So this might motivate you to get rid of them. Of course, the simplest way, some people do in the exam, just drop them. Then you will get the answer. But of course, this is actually not a very fair way to get rid of cosines. So what should I do? If you cannot, I will give you a little bit more hint. So that, first of all, I hope everyone understands that in some mathematical, legal way, we have to get rid of cosine squared u, cosine squared u and v. Yes?
I don't know what it's called in English, but Trigonometric Identity.
Yes, that's your identity, whatever you want to call. So this is very important skill to have in mind. Whenever you want to get rid of sine in favor of cosine, Or,
Sine.
so if, whenever you want to, let me write it with theta, not with u and theta. So that is in general. This formula is very, very important in trigonometry. So whenever you want to get rid of sine in favor of cosine, you can. Yes, whenever you want to get rid of cosine in favor of sine, you can. But this becomes useful if you have an even power. Because if I want to find sine squared theta, let me write cosine squared theta. If I want to write cosine squared theta, it becomes 1 minus sine squared theta. But if I insist to continue, I take a square root, then I will have problems because I have to put plus and minus. Yes? So this is why this formula is useful to eliminate one of them in favor of the other one, especially if I have powers of 2 or even powers. So that's important. Otherwise, if I have odd powers, I have to take a square root sign. First of all, I have to deal with this ugly square root sign. And the other thing is that I have to work with 2 of them, plus and minus. Okay? So these are the things I want you to understand. So here, do I need to change sine squared u at all? No, because I look at the right-hand side, I have it. So let us don't touch it. But should I get rid of cosine squared v? The answer is yes. I don't like it. Okay? But what can I do? Yes, what can I do? Instead of cosine squared v, what can I write? 1 minus sine squared v. Understandable or not? Yes? And then I go minus, do I touch this one? No, I like it. And then, do I touch this? Yes, I hate it. Yes? Now at least you see something that is only involved with sine and sines. Sine u, sine v. That's so far so good. Okay? But then that is not your responsibility. Just try to simplify that. What is the natural step? To multiply. Yes? So it becomes sine squared u minus sine squared u times sine squared v. And then I multiply that. It becomes minus sine squared v. Tell me, what is the next one? What's the next one? If you say minus, I have to kill myself, okay? It should be plus, yes? Because I have seen people write it minus, they see that some problem arises, then they put everything under the rug, you know, some solutions, because they want to just get A points, you know? But this, if you patiently think, you see that this would be positive. Because I am multiplying this negative by that negative, it becomes positive, and that's extremely important to have that one positive. Why? Because this combination is exactly the same combination here. One of them negative, one of them positive, so they cancel out. So what is left for me is sine squared u minus sine squared v. Yes? And that is exactly equal to the right-hand side. Yes or no?
Yes.
So this was one of those problems that I published for interested students, but that was a mistake, because that's at the level of your lesson. So don't complain if I give some question like this in the exam. Okay, so that's not something that is hard. Yes or no? Understand it? Let me give you another problem from that problem set, and I want to wait for you to solve it for me, then I will start the new lesson, okay? Okay, so example, I want you to prove this. It is very similar, but I just want to have a practice for these ideas. Repeat these ideas for yourself once more. Show that for every angles u and v, we have this. I want to write a very similar question. Cosine of u minus v multiplied by cosine of u plus v. But something strange happens here. It becomes cosine squared of u, but minus sine squared of v. Yes? I will pause the video and wait for you for 5 minutes, and then we come back and solve it, and then start the new lesson today. So now we start, okay? Is any volunteer now? No one from technique program? Kevin?
You can look at my solution so far. It's not, I haven't finished it.
Yeah, it's finished. Just come.
No.
But that's exactly the same thing, just one more step.
Yeah, and I can't solve that last step.
No, then I can help you. Then I can help you.
Okay.
Yes, come. I don't want to put pressure on you, but I want you to come, okay? And then I have to tell you that you will be on YouTube, okay?
Oh, it's fine.
Yes, good.
Get him something.
So, I don't know which marker would be suitable for you.
I'm
Yes,
not
you
sure.
can start on this one. And try to explain, not just your solutions, yes?
Yes, okay. So,
Yeah, please listen. Okay.
I begin using the formula for cosine u minus v and cosine u plus v. So this one.
Yes.
And I exchange them to
Yes.
this.
Yes.
So first I write oh, and I can write this also.
Yes, that's important. Yes.
V, and then I close this.
Yes.
And then okay, I wrote it very big. So
No problems. You just put
Yeah,
that
so-
and come. Yeah, no problems.
it continues.
Yes.
And then for this one,
This one.
I use the same formula.
Yes.
So yeah.
Yeah, bracket
close.
plus. So if I were you, what you have written is 100% correct. But if I were you, when you want to teach
I
someone,
should write it on one.
so no problem about that. That you will learn. But this one is minus. Of course, what you have written, there is no difference if I interchange them. But the minus sign is with positive sign,
Oh,
and the positive sign is with the minus sign. So if I were you, I would write this positive and this negative to keep the order and being organized.
yes, of course.
So let us just change that. That's positive, and that would be negative. Of course, what he wrote was completely correct, but let us be organized in mathematics. Okay,
Yes.
and then
And then I go on, because then I recognize this is conjugate pattern.
pattern. Yes.
So I can just do this and write the first one to the power of 2.
Yes.
And then it becomes a minus. The second one also to the power of 2.
Yes.
And as you explained earlier, this plays then the role of like A,
Yes.
and this is the role of B.
Yes. Yes.
After that, I can just remove the parentheses and apply the power to each and every cosine and sine. So yeah.
Yes. Very good.
And now I use the identity. I don't know what the name is in English.
I don't know. You said eton, so that's now famous for eton, yes. So we use eton identity. What's eton?
Yeah.
But explain your strategy.
Yeah, so my strategy here is I want cosine squared u and sine squared u. So
V, sine squared v.
oh, v,
Yes.
of course. So the ones I want to drop or get rid of are sine
Now,
u
please keep quiet.
and cosine v.
Yes.
So those are the ones I'm gonna interchange.
So exactly.
So I'm gonna keep cosine squared
U.
u,
Yes.
and then cosine v becomes wait 1 minus sine squared v.
Exactly.
Should I explain this or like write it?
No, it's clear.
Yeah.
Minus.
Minus, and then I want to exchange sine u.
Yes. Yes.
So I write,
You need to write a little bit small there. Yes.
yeah, 1
Minus.
minus cosine of u.
Squared. And there's something coming after that.
Yeah, I can just write it here.
Yes, no problem.
Times sine of v squared.
Very good. So the strategy working. So this is immediately clear because we want to keep cosine squared u and sine squared v. We want to get rid of the other two. So that's the only way that we can do that. And then the rest of it is just simple algebra. And
Yeah,
if you cannot do that, I can help you. The first one, you do not have any problem. Just multiply.
Yeah, I can just multiply.
Just write it from, it starts from a little bit left hand side, yes.
And then I can just write cosine squared u minus sine squared v
Yes.
minus, and here I'm not completely sure.
No.
Of course,
Be careful. Be careful. You have multiplied this inside. The first one is correct. What would be the second one? Because you are multiplying.
but because you should multiply cosine u with sine v
As well. Yes.
But it
So because this is, if I have A, B minus C, you take this one, multiply it here, you take this one and multiply it here.
yeah, but that was the thing. I thought it was kind of odd writing.
No. You need to follow the rules. Don't trust your instincts, yes?
Yeah, but
Yet.
So
Yes.
so it becomes
Yes.
cosine
Squared
u
sine squared v.
Yeah,
Yes. Why do you
sine
doubt?
squared
So if you still doubt, please let me know to explain it for you.
No, I don't doubt this, but I don't
That's
know
correct.
what to do with it later.
No, don't. So that's one mistake. You are not able to see the whole problem. Even I don't do that. I have to calculate. Might be it doesn't work. I have to cross it over and do it again. Okay? But because of that problem that you don't know what to do with this, so let us ignore this. This is not a good idea. Okay?
Yeah,
Yes.
so I multiplied that inside.
Yes. But then
Then
you
it becomes.
I'm close to kill myself.
No, wait. Because it's positive sine squared
Yes.
multiplied by the 1.
Yes. That's
So-
correct. That's correct.
The minus sign
That's
we
good.
should keep.
Yes. The next
Uh,
one I am talking about.
And then it's minus cosine squared multiplied by sine
So,
squared.
so this is very important to write it properly. You see, this is the way that you have written it down. This is, by the way, it's very important, but your handwriting is very good in the exam. So what is that? Cosine squared u,
Yeah.
and then I have sine squared v. By the way, be careful. Writing it properly will help you to solve the problem without mistakes. Okay, now can you multiply them here? So you can see this and write your answer there. So you already multiplied that here, and then you have a minus sign. So you wrote minus sine squared. That's correct. The next one.
I mean, it should be minus as well.
No, a minus. When you multiply, it is a minus. Another minus will go from there.
Yeah, that's true.
So that was the
So
problem.
that should be a positive one.
Positive one.
So it would be simpler if I wrote
The other way.
Yeah.
Yes, but you shouldn't get confused about these things. Okay?
Yeah, of course. And then I can just write cosine squared u sine squared v.
Just wait a little bit. Everyone understands what is happening here?
Yes.
Everyone? Okay.
Oh yeah, and then these two cancel each
That
other
was the
out.
one that you were worried about.
Yeah.
Yes? So I told you that the problem is solved.
Yeah, and then you have just
Cosine squared u minus sine squared v, and then don't forget to write is equal to the right hand side. Yes?
Yes.
Okay, thank you. So it was not that hard feeling, yes? Okay, 2-1. Yes? Yes, please, Amanda.
Next time you do any question, please don't have you and me because it's very hard to distinguish.
Yes, I agree with you. I agree with you. Yes. I have to write this. The problem is that the book is following you, and this sometimes I wrote. Yeah. Yes, but you are right. I will not do that. Okay. Any questions? Now let us go to the new lesson. Yeah, let me just start writing here. Okay, so my question for you is that if you see we want to talk about double angle formulas, let us just concentrate on double angle formulas. What's the meaning of that? So my question is that if I want to write a formula for sine of the double angle, I have an angle theta, I multiply it by 2, and I want, for example, to calculate sine of that double angle. Is there any formula that I can write in front? Let me remind you of something. So do you remember we had a formula like this, minus theta. What can I write for this? This is a famous, I told you about this. If I have a negative sign in front of sine, what can I do with that negative sign? Yes, Inura? I can pull that minus sign out. So this is a little bit of confusion. This sometimes brings you confusion. So you might think, because another name of this is, instead of minus theta, do you agree I can write minus 1 theta? And instead of minus sine theta, I can write minus 1 multiplied by sine theta. This might give you this wrong impression that whatever you have here, you can pull it out, which is completely wrong. Yes, that was the only exception. Minus 1 is the only exception that if you have it in front of sine, you can pull it out. But that is the only number that works in that way. And if you remember, for cosine, even if this doesn't work. What was the formula for cosine of minus theta? It was just cosine theta, so this is just completely gone. But I want to answer something like this. What happens if I multiply my angle by 2 and then take cosine? And usually we do not put pair of brackets, even though some books they actually put pair of brackets. But it is unnecessary. So I'm following most standards. Even your book, you don't have that in pair of brackets. Yes? So do not interpret this as sine of 2 multiplied by theta. No, it is sine of 2 theta as a package. Yes? So we want to find a formula for sine 2 theta. Yes? So what should I do? Yes, Dylan?
Can you write it as theta plus theta?
Plus theta. Yes, that's the only thing that we can do. So the question mark here, sine 2 theta. Of course, another name for 2 theta is to write theta plus theta. And I give the role of u and v to these thetas. And then I write the first formula on top. So it becomes the sine of the first one multiplied by the cosine of the second one plus the sine of the second one, which is of course theta again, multiplied by the cosine of the first one. So what can I see? I can see that the same combination appears 2 times and I'm adding them. So it becomes 2 times this combination. So we got our formula. So this is one of the very important formulas in trigonometry. Yes? So, I don't know why they have separated these topics, but that can also be viewed as half-angle formula. What is important is this. So, it's very, very important, by the way. I know that you will not memorize them, but the combinations, the famous combinations in trigonometry should be famous and familiar to you. Otherwise, you will have a lot of trouble. So one famous is sine squared plus cosine squared. This is a famous combination. Even if you forget the details, but you need still to know this is a famous combination. Okay? This multiplication of sine and cosine of the angles is a famous combination. Yes? If I ask you what is sine theta, cosine theta, you can divide by 2 and say that 1 over 2 sine 2 theta is this combination. Okay, so, but what is important is not 2 theta or whatever. This means that whatever you have here, which is 2 theta, you divide it by 2 and write it here and here. Yes? So, for example, if I ask you what is sine of theta, you might say that, okay, sine theta is sine theta. But if you insist, you can still write something in front of it. Okay? What you can write 2 sine of what? What appears here is this one divided by 2. Now, what is appearing here is just theta. So, if you divide it by 2, it becomes theta over 2. Multiplied, so let us put it in brackets, cosine theta over 2. So the book has written this formula under the title of half-angle formula and have written this formula under the title of the double-angle formula. But they are actually the same thing. I do not want to make this distinction for you to see that they are different formulas. So you can also talk about quarter formulas. Yes? For example, what do you think I can write in front of this? If I write sine theta over 2 here from the beginning, if I want to, what can I write? I can write 2 times sine. This angle that appears here divided by 2, this time it becomes 4. And then I will multiply it by cosine theta over 4. Yes? So this, you don't need to have that distinction between double and half because you can produce even lower fractions with just playing around with this concept. Yes, is that clear? So what I'm saying is that I don't remember exactly. I think you will be given only this formula in the exam on the formula sheet. So the half-angle formulas, you need to learn how to discover them yourself if you need them. Is that clear? Yes or no? Okay. So now, for example, let me just give you no, before giving you an example, let me discover the formula for cosine 2 theta. Okay? So what would be the formula for cosine 2 theta? And then we can solve some examples together. So cosine 2 theta, I don't need to prepare a bracket, so 2 theta. Of course, the method is as the same as before. Yes, it becomes cosine of theta plus theta. Yes, but then I have the formula for cosine up there, so it becomes cosine of the first one multiplied by cosine of the second one, which coincidentally are the same, minus sine of the first one multiplied by sine of the second one. But there is a better way of writing cosine times cosine, and that is cosine squared. Yes? So this becomes cosine squared. And then I have negative sine squared. And then this is a little bit of matter of confusion for students. So that formula that we called it eton is the same combination with positive sign in between. And that would be always equal to 1. But here, I have the difference between the squares of sine and cosine, and it is important to write cosine first because cosine squared minus sine squared is not the same as sine squared minus cosine squared. So the order is very important here. So what we discover for cosine 2 theta is this formula. So it becomes cosine squared theta minus sine squared theta. So be careful. Both of these combinations are famous in math, in trigonometry. Cosine squared plus sine squared, which becomes 1 always, and cosine squared minus sine squared. It is not always equal to 1, but there is a formula for that, which is also a very famous one, and that is cosine of the angle multiplied by 2. For example, if I ask you, can you answer this question? Yes, so you see this combination should look familiar for you. Otherwise, you don't know even there is a formula for that. So you see, I can compare this combination with that combination. So what is playing the role of theta in this problem? 22.5 degrees is playing the role of that theta. So if this formula is familiar for you, and if you forget about what is the exact form, then this will motivate you to go and look for it. But if this is not clear, then you have to just stare at it, yes? Yes? So what happens, what can I write here? It becomes what? Cosine of 2 times that angle. But we know what is 2 times 2 and 2.5. It becomes 45, and then 45 is one of those famous angles. And if you refer to the table in the back of the formula sheet, you will get that this answer is square root of 2 over 2. For example, these kinds of combinations might be asked. There are some exercises in the book you can solve. But for this one, the book and the formula sheet presents 2 more formulas. Because if I ask you, how can I calculate cosine of the double angle, you would say that I need cosine and sine of the half of the angle. But sometimes you have only sine, sometimes you have only cosine. But that's a matter of changing one of them, getting rid of one of them in favor of the other one. So for example, if I use the etan formula here, let me just write it with a different color. So I can, instead of this one, I can write 1 minus sine squared theta. Do you agree?
Yes.
And then after that I have minus sine squared theta. And then if I ask you what happens with this, I don't need to have these pair of brackets, I just remove them. Minus sine squared is minus 2 sine squared. So one of the formulas which is given in the formula sheet and in the book for cosine 2 theta is this formula. This formula is expressed in terms of both cosine and sine. This formula is the answer to the same thing, but expressed solely in terms of sine squared. Yes, I can also do the other way around. For example, I can eliminate sine in favor of cosine. So what happens? It becomes cosine squared theta, and then I have minus 1 minus cosine squared theta. So what happens? It becomes minus 1, but minus minus becomes positive. Added to this, it becomes positive 2 cosine squared theta, and then I have minus 1. Yes? So these 3 formulas, let me write them here, which are given in the book. So for sine 2 theta, we have only one combination. But for cosine 2 theta, in principle, I have one combination, but I can write it in 3 different ways. Yes? So cosine 2 theta, the standard formula would be the difference of these squares, which is actually very important to know. And then you can write it only in terms of sine if you want to. And you can also write it only in terms of cosine if you want to. So these are the formulas presented for the cosine of 2 theta in the book and in the formula sheet. Yes? And of course, is it necessary to talk about half angles? No. For example, can you tell me what would be the answer to this? Cosine squared theta over 8 minus sine squared theta over 8. If I insist to write something in front of it, what can you write in front? Using this topic that I'm discussing. Yes?
Cosine theta over 4.
Exactly. Understandable for everyone? So you need to interpret it in this way. Of course, when you see 2 theta, you might think that this is only working for 2 theta. No. The relation is important. So because if you see a factor of 2 in front of your angle, you can eliminate that factor of 2 and write theta. So here, this is the same story. Here I can, but of course in this direction, when I am going in this direction, I have to divide my angle by 2. If I want to go back, I have to multiply by 2. Is that understandable? So this combination, understanding the combination is important. So this becomes cosine. I have to multiply this by 2. And as you told, it becomes what? Cosine of theta over 4. So if you see this, this is not strange. That's exactly the same formula. So you see that we don't need to actually have a distinction between half an angle or double angle or I don't know, eighth of an angle. So whatever you want to, if necessary, you can discover yourself. But you need to know how to do that. Yes? Understandable or not? Yes? When the time finishes? I always forget.
In 30 minutes.
Okay, so we have time. So let us, I think there is a good problem in the book. Let me just solve that problem. Let us solve it together. Again, let me write important, okay? So let me add these formulas in our list here. So we got another formula. So we learned that, let us repeat this a little bit. So not formula number 3 that we discovered today is that if I have the sine of any angle, 2 times that angle, I can write 2 times sine and then divide that angle by 2 multiplied by the cosine of half of that angle. And then we have another formula that if I want to do the same thing for cosine 2 theta, I can write it in 3 different ways. All of them are actually the same formula. One of them is this, one of them would be this, and one of them would be this. Yes? So these are also formulas that will be given to you. Okay, so there is a question in the book. I want to change the numbers, but let me just tell you this problem. So example. Let me change the form of the problem a little bit. So let sine theta be 0.6 and let theta lies on the second quadrant. Determine. So let me write, this is important. This is one of those problems that are important. So every now and then, when I write important, by the way, that's not a secret. It means that it would be on the exam, something like that. Important. Okay, so determine, not exactly the same question, the same idea will be asked. Okay, determine the exact value of tangent of 2 theta. Okay? Which we don't have any direct formula. Of course, in the book, they didn't ask you about this. They asked you about the exact value for cosine of 2 theta. But I want to make it a little bit harder, but that's also something we can do. So, let us do it together, yes? Because I want to finalize this lesson. But you can help me to do that by communicating with me. So what should I do? So first of all, I want to talk about tangent of 2 times theta. But the information provided for me in the problem is not related to 2 theta, is related to theta. So I need to understand how to extract the wanted information from this piece of information. Okay. So, tangent 2 theta, I will not face any problems because can I write tangent 2 theta is equal to sine 2 theta divided by cosine 2 theta? Yes? So if I want to calculate tangent of any angle, I can calculate its sine, I can calculate its cosine, and then divide them together. So that's the most fundamental way of calculating tangents. So this means that indirectly, I need to find sine 2 theta and cosine 2 theta. But the formulas are in front of your eyes. If I want to calculate sine 2 theta, there are two ingredients that I need. One of them is sine theta, which is provided for me in the problem directly. But another one is this one. Do you remember I had these problems before? I told you that these are prototype examples and I wrote important for them because there are a lot of applications whenever you learn something. So if I want to solve this problem, I know that I know sine theta, I need to find cosine theta. So this is another problem that we had before. So what you write cosine squared theta plus sine squared theta is equal to 1. Cosine squared theta is missing for you, but sine squared is that number to power 2 is equal to 1. Okay, so cosine squared theta plus this becomes 0.36 is equal to 1. So cosine squared theta becomes 0.64. So cosine theta becomes plus or minus 0.8. Yes? And which one is acceptable in this case? This sentence becomes important. Because theta is in the second quadrant, cosine has to be negative. Yes? So, in the second quadrant, cosine is negative. So what I get, therefore, cosine theta is minus 0.8. Yes? And now everything is ready for actually both of them. Yes? So, but if my goal was to calculate cosine 2 theta, which formula was more suitable? I have three formulas for cosine 2 theta. Instead of tangent of theta, assume that I have given you cosine 2 theta to calculate. Of course you can use this formula, but you have to calculate cosine as well. But the lowest one is more suitable. You just put this number there and you are done. Yes? And I will do the same thing here. So let me write the formulas. So I would write the formulas in the exam in front of the person who is supposed to correct the papers, probably me. And then this becomes 2 times, what is sine theta? It's given in the problem, 0.6. If you don't mind, let me write cross for the product, not to get confused with this decimal point. And then multiplied by cosine theta, which is minus 0.8. So what the answer is minus 0.96. So sine 2 theta is minus 0.96. Agree? And now I want to calculate cosine 2 theta, but let me use the last formula. Cosine theta, in this context, of course it doesn't matter because now I have both of them. So even if you want, you can use the first or the second. But logically, it would be better to use the third one, which just only needs the information given the problem itself. So then this becomes 1 minus 2 times, what is sine? Is 0.6 to power 2. So then it becomes 1 minus 0.72. So this becomes 0.18. Am I right? No, 28. 28, thank you. Double check, yes. So cosine 2 theta is 0.28. Yes? Now what I want to calculate, so therefore the question mark, which is tangent of 2 theta, can be written as sine of 2 theta. Every tangent can be split as sine and cosine. But now I have all the numbers. Sine 2 theta is minus 0.96 divided by 0.28. and then I don't know, I can, for example, write it as, I can multiply by 100 if I want to simplify that. So I can divide by 2, 14, and then by 2, so it becomes 7, 24, if I am right. Yes? So the answer to the problem is minus 24 over 7. Understandable?
Yes.
Okay, so this is one of the examples. So you see, this is nothing. If you understand the core, you can play around with the formulas and everything. So if you understand what is going on, so you have more and more formulas in front of you. That's it. And then you know what to do with those formulas. Okay, let me ask you one question. In this, I want to test your understanding. So, before calculating sine 2 theta, did you expect to get a negative number? Yes or no? Because of course I calculated, I got a negative number, minus 0.96 for sine 2 theta. But could you predict, even before starting any calculations, could you predict that the value for sine should be negative?
Yes,
How?
it's in the second quadrant.
Because one is 32.
No, theta is in the second quadrant. And it's, of course, in the second quadrant sine is positive. But it needs more.
And the cosine is negative. Meaning that if you divide them, it's negative number.
No, again, you are calculating something. You are using the formula, which of course is correct. But could you expect sine of 2 theta should be 0. minus a negative number? Why is that? Except the formula. Just by reading, assume that you don't know this formula. This is my question. Might be I have to correct myself. Assume that you don't know the formula, and you read this, and you want to predict, is sine 2 theta positive or negative? You can still predict that. Yes, Elias?
Well, by doubling the angle, it means no longer in the same quadrant, and it could be one of the bottom.
So because, yes, very good, thank you. So theta is in the second quadrant. It's somewhere between 90 degrees and 180, for example. And if you double it in size, what happens? It will go to which quadrant? Fourth, not the third. Yes? Because you have an angle between, it's greater than 90, smaller than 100. No, it's not guaranteed, yes. So it might be between 3 and 4. Yes? But in any way, sine is negative. But now I'm asking you the question, in this situation that you see on the board, when you double it, is it in the third or in the fourth? Because now you have some numbers in front of you. You see, sine of 2 theta is not negative, cosine of 2 theta is positive. So even though theta itself is in the second quadrant, but the 2 theta in principle could be in the third quadrant, but it is not. 2 theta is an angle, so that when you multiply it, it becomes in the fourth quadrant, because sine is negative, cosine is positive. Yes? So for example, theta cannot be 100 degrees. Yes, 100 degree is in the second quadrant. But 2 times 100 degrees, 200 degrees, which is in the third quadrant. So theta should be bigger than 100. Yes? So theta is bigger than 135 degrees. Yes? Because 135 multiplied by 2 becomes 270. So my angle should be bigger so that it goes to the fourth quadrant. Is that understandable? You can think about it, it's understandable. So what we can see is that even if I don't know the exact value for my angle, I can predict that this angle is larger than 135 degrees. Yes? Because if it was smaller than 135 degrees, when I multiply it, it will end up in the third degree. Because the final point for the third quadrant, the final point is 270. Yes? So this means that this angle, even I don't know, I can estimate this angle is somewhere between 135 and 180 degrees. I'm just asking these questions so that you have to get engaged to understand these concepts. But that's finished. This problem is finished. You can be happy. Yes? Any questions? So actually I taught you these two parts, but I will remain on this for the next session by bringing you more examples and exercises. Okay? Again, when do you think we will finish? In 15 minutes. Let me ask you some questions which I also published in these problems for interested students. I want you to find a formula for sine of 3 theta. Okay, but in this way. I want you to find a formula for sine of 3 theta, but I want you to express it only in terms of sine. Okay? So let me write this example for you. Express sine of 3 theta in terms of, by the way, this way of writing should be familiar. I'm using this word a lot. So express sine theta in terms of sine theta. What does it mean? It means to give me a formula so that if I have your formula and you give me sine theta, I put that number in that formula and I get sine 3 times of that angle. So that is the goal of this question. So, okay, just do it. Yes, start doing it. In principle, you should be able to do it. Whatever you need is on the board. So to make sure that you are on the right track, where is your starting point? So you are on the wrong track, yes. So where is your starting point to calculate something for sine 3 theta? Where is the starting point? Yes?
Sine theta plus theta plus theta.
This is in principle correct, but it is not that useful. Can you tell why? Because addition formula is only for 2 angles involved, yes? Because if that was completely correct. The idea was completely right. If you write sine theta plus theta plus theta, that's correct. But the formula, addition formulas are not related to 3 angles, are related to 2 angles. Elias, can you yourself correct it now? Yes?
So if you calculate sin theta plus theta, and then you will get sin 2 theta, and you not just then do sin 2 theta plus theta.
Yes, so it means that the starting point is now revealed, yes? So sine 3 theta, if you write it theta plus theta plus theta, the downside is that I do not have any formula for the sine of the sum of 3 angles. But I can write it as sine 2 theta plus theta. Is that understandable? Because 2 theta plus theta is the same as 3 theta. Can I apply the addition formula now? Yes, because how many angles you see in front of you? 2. One of them, so this will play the role of U. This will play the role of V. And then continue. I want to wait for you. Okay, so let me, if you go to see the problems for interested students, I have written the formulas there and I have asked you to show them. This is the formula for sine 3 theta. There is also a similar formula for cosine 3 theta, but expressed in terms of cosine theta. This is the way that you have to learn. If you really want to learn, if you missed the minus sign or something here, you should be able to solve the other problem without any errors. So try to go and solve a formula, find a formula for cosine of 3 theta. It's a similar combination, but instead of sine, it turns out the answer would be in terms of cosine. Okay? So this is the way that you have to practice and learn this. Next time, I will keep this lesson. So I will not teach a new lesson. I will bring some new exercises and examples so that we can work on. Because that's a very important topic. Okay, thank you very much and have a nice weekend.